All right, what we want to take a look at today a little bit is this idea of what are called logarithms. Perhaps you've heard of them, perhaps not, but you will have heard of them anyway. After today. Turns out that what logarithms are, they are the inverse function of the exponentials, and so hence that's why we're talking about them now. I haven't mentioned before the idea of the inverse function, but pretty simple idea. Inverse function. If I have a function f of x equals x squared, then what function would be the inverse of that? In other words, what would be the thing that would undo that particular function? Because this takes and squares it, and so the inverse of it would be something that would take it and square root it. Square root of that would be the inverse of it. For example, like if I had x is 2, then the y would be 4, right? Well, if I take that result, the 4, and then plug it into this one, what happens? Well, it goes back to 2, right? And so these are the inverse of one another. Inverse in that, among other things, the x and y's are inverted, right? Here's the x, here's the y. Well, here's the y and here's the x, and it works the same way. If I went with 3, 9, right, that would be a pair over here. What's the pair over here? It'd be 9, 3, wouldn't it? Plug in 9 to get 3. So that's the inverse function. That's what it does. It will undo what your original function did. Well, that's how the logarithm and the exponential are related. They're inverse functions of one another. The logarithm is the inverse function of the exponential. And that reason I mention that is because that's one of the things here that will connect up here, logarithms and exponentials. But that's and there's application of logarithms. You will see logarithms. Anybody know one? Know of a logarithm definition? Something we haven't heard about a lot lately, but earthquakes. Their scale is based on a logarithmic scale, their intensity. So that's just one of the things. We'll maybe perhaps see some others. Sound also can be measured in a logarithmic scale, but there's in science there's quite a few things that use the logarithm scale. So I guess the best way to start this off is with a definition of logarithms, and this is it. The logarithm, base A, of the value x is defined this way. Well, first of all, just a notation. LOG for logarithm, makes sense. There. Yeah, logarithms are like exponentials. You know, exponentials, we have a base in our exponential expression. Well, logarithms also have a base. And the base in the notation is written right here. So that'll be our base. And the value we're taking the logarithm of, the x, sometimes called the argument, so that value that we're taking the logarithm of, this is how it's written. Log base A of x. That's the way we say that. equals, well, it's equal to some value, call it y, just in general. But this logarithm equals that value if and only if a to the y power equals x. And so hence there's our connection. That's an exponential thing, right? A to a power equals x. All right. And so for obvious reasons, this is referred to as the exponential form of a logarithm. And this, of course, is the log form. For obviously there, hopefully. All right. Now, just a quick note here of how this is working. Like we said, this is the base, so makes sense. What is A over here? It's the base, right? You got A as your base. Now, the other important concept here is where this value comes from. The power of the base in the exponential comes from where? It comes from this side over here. And then the x is, well, it's over on a side by itself there and that's what we're going to do here first is let's change these logarithms to exponential form. All right, number one is log base 4 of 64 equals 3. That's a true logarithm right there. And if we change it to the exponential form, well, the exponential form, we start with the base. What's the base here? The base is the 4. Then the power, well, the power, like we said, the power, when we have the logarithm written out this way, the power comes from, the power comes from, is that better? A little better there? You go. All right, the power comes from the number over here, right? 4 to the third equals 64. So this one goes here, this is the power, and then this is what those equal. All right? So that's the conversion from one form to the other. Now, having changed it to that form, we can see that this is true enough. This is true, right? Because 4 to the third does equal 64, doesn't it? 4 times 4 times 4 does equal 64. Okay, so this is a valid statement because we know that is a valid statement right there. The two are the same. Okay? All right, here's number 2 then. I'll try to keep the board up here. Okay. All right, change this one to exponential form. Log base 3 of 9 equals, let's change that. Log base 3 of 1/9 equals -2. All right. So that in the exponential form would be, the base is 3, so in exponential that's the base. What's the power? Well, the power is this number right here, 3 to the -2. That equals 1/9. So this is the power, and this is what 3 to that power equals. Okay? All right, well, that brings out a couple of things here. That what a logarithm, one thing you can think of a logarithm as being is a logarithm is a power, right? Because this logarithm equals this. Well, this is a power. So basically a logarithm is a power. What power is it? Well, it's the power of this that gives me that. 3 to the -2 is 1/9. So this to that power is 1/9. So that's what a logarithm is. It's basically it's a power that I'm looking at. Now, a couple of other things also is that there are some restrictions here on what we can have in these logarithms. So I might go back to this one and note here. On my logarithms, there are some restrictions. Base A, well, it has to be, generally speaking, we make it something bigger than 0, positive. We're dealing with real numbers here. So A, the value of A, the base, needs to be a positive base. And then as well, the x value also has to be greater than 0. And one other thing. The base A doesn't need to be 1 either. So there is a restriction on the positive side of it. We want it to be positive and A not equal to 1. Because if A is 1, can we get anything besides if we do 1 to a power? Is there anything else we can get other than 1 here? No. So that's why there's usually not a logarithm of base 1, because 1 to a power is just 1. But then also, and we'll talk more about this, the x value also has to be greater than 0. So we're not going to plug any negatives in here either. But those restrictions will be in place. Now, and that's why I went with this one. What about y? We said a has to be greater than 0 and x has to be greater than 0, but does y have to be greater than 0? Well, no, because we just saw one where the y was a negative 2. So we can have the y values be negative. So it's just the a and the x. And really, what we'll make note of on a lot of occasions is you can't take the log of a negative number in the real number system. You cannot take the log of a negative number. So the x has to be something bigger. And we'll talk more about that in just a second. All right, well, let's go the other way. Change these to log form, or logarithmic form. 7 to the third equals 343. What would log form right there that be? Well, we've got log. And on a logarithm, you always need a base. What's the base of this logarithm? Well, it's the base of the exponential we got. So 7. 7 is my base here, so it's 7 is the base here. So the base 7 is the subscript on the log. All right. What am I taking the logarithm of here? Well, it reverses now. I'm doing log base a of x equals y. Well, what's the x in this setup? Here's the x, so what's the x here? It's the 343. So I'm doing the log base 7 of 343 equals then the power 3. So that's how it goes. It goes both ways. One and the other are the same. Okay? All right. Now, is that all right? Any questions on that? Okay. Well, the big thing that we need to do then is to be able to evaluate logarithms on our own. And so let's spend a little time evaluating logarithms. All right, log number 1. Log base 4 of 16. So we come across a logarithm. We don't know the value of it. Here's one way we can approach this. what we're saying is this logarithm equals something. Some number. A logarithm equals some number of things like this. And the way I like to explain it is, let's just convert that to exponential power, exponential form. Log base 4 of 16 equals something. So what would that be in exponential form? Well, it would be 4 to my unknown equals 16, wouldn't it? So if I put it in those terms, hopefully then we can kind of get an idea of what this logarithm should equal. If it's got to be 4 to this equals 16, then what does the question mark need to be? Probably 2, okay? Question mark is 2. So that's the value of this logarithm, yes. It's 4 to the second equals 16. So the value of this logarithm is 2. Okay? All right, what about this one? Second one. Log base 3 of 1/27. We had a similar one a while ago. Well, again, this is something. What does it mean? Well, in exponential form, it means 3 to the power of what equals 1/27. Well, I know that 3 to the third power gives me 27, but how am I going to get 1 over 27? Well, that's going to be not 3 to the third is 20. 3 to the third is 27, so it's not 3 to the third. How am I going to get 1/27? Do a negative 3, yeah. Yeah, if the power is negative 3 instead of positive 3, that's going to mean flip it over and then do 3 to the third. So if my power is negative 3, this all works out. So that's the value of my logarithm. All right? So as we said before, you can get negative numbers for these logarithms. Let's talk about this one. And again, the base, just about any positive number can be the base there. Or it can be any positive number. We'll stick with integers mainly. All right, what does this one equal? Well, we've got 5 to what power is negative 25? Well, let's talk about that. To the side here, we know that 5 squared gives me 25. So is it 5 to the negative 2? Well, no. That's not going to be what we need here. We can't do the negative 2 power. Why? What does that give me? If I do the negative 2 power of 5, what does that give me? Well, that gives me not negative 25. That flips it over and makes it 1 over 5 squared, or 1/25. So that doesn't give me negative 25. That gives me 1/25. So what shall we do? There's not one, is there? That's about the only thing I could think of to do to get 25 out of the deal. 5 to the power get me 25. Yeah, there's just not a way to get 5 to a power equal to negative 25 in the real number system. So, not a real number. Maybe if we wanted to go to other numbering systems, we could, but we don't want to, right? Not right now, anyway. Okay? That's not a real number. So yeah, that's what we're saying. This number, what we take the log of, you can't take the log of a negative number. Emphasize that. Okay? Number 4. Log base, what if we have log base 5 of 1? Can we do that one? Yeah, that's 5 to what power gives me 1, right? It'd be 0, yeah. Our power here, the question mark, doesn't that need to be 0? Yeah, something to the 0 power is always 1. So 5 to the 0 gives me 1. So this logarithm is 0. Okay? What about log base 7 of 0? Is that 1? Now let's see. Isn't that asking me to find what power of 7 gives me 0? Can we think of a number to a power that gives me 0? Well, we've already said if we do 7 to the 0, that gives me 1. So that's out. Can't be 0. What else you want to try? Any negatives? Positives? I don't think so. Any power of 7 is going to give me something other than 0, isn't it? Same as number 3 there. It's not a real number. So not only can you not take the log of a negative number, you can't take the log of what else? 0. That's what we're saying. X, this number, has to be something greater than 0. It can't be 0, and it can't be a negative number. Okay? Just doesn't work out. All right? Now, we do get logarithms equal to 0. We just can't take the log of 0. We do get numbers, logarithms equal to a negative number. We just can't take the log of negative numbers. So make sure you understand that difference. All right, got one more. Maybe 2. Whoop. These two the same thing? Slight difference here, isn't there? The difference is the bases, and I've switched them around. Okay, so let's talk about it. This one right here, we're wanting what? The base is 64, so am I not wanting 64 to a power equals 8? Right? This one over here is probably the one we would think of when we see this problem. This is 8 to what power is 64, is it? Well, I would say this one is a much easier one than this one. This one, what do you got? 2? That power would be 2, wouldn't it? Question mark, the power needs to be 2. So that's, yeah, this is 2. This one's not 2, though. Because 64 squared is not 8. Okay. 64 squared is a big number. So it's not 64, it's not 2. So what we have to realize here is, there is, of course, a squaring relationship there. However, it's not that you square 64 to get 8. What could we do to 64 to get 8? We could square root 64 and get 8. Okay? That's a good note there to note. Good observation to note there. Because I don't know that we've mentioned it yet in this class. Maybe we have. How can I write a square root as a power? Isn't there a connection between a square root and a power? If I have the square root of a number, how can I write that as a power? Square root of x equals x to the... Anybody? It's 1/2. Square root of x is x to the 1/2. What's the cube root of x? X to the 1/3. Yes. If you have a root, the root is the denominator. Square root, so we have root 2. So that's the denominator. Cube root, so the denominator over here in the power is, so the root is the denominator of the power. Okay? This one's square root, root 2. So this is 1/2 power. All right. So anyway, back to this. So we've got the square root of 64 does equal 8. So doesn't that mean 64 to the 1/2 equals 8? So what's my log base 64 of 8? It's 1/2. With me? This is okay. All right. So you might have to look for those square roots or cube roots even. We'll talk more about those along the way. Okay? Now, all this being said, there's still some. Let's do one more here. What about the log base 2 of 30? That equals what? Well, we're looking for 2 to what power gives me 30? Well, if you don't know what it is, just try powers. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth, what is it? What's 2 to the fifth? 32. So just by that work alone, what do you say? What would you say? What is 2 to what power is 30? 15? No. Okay. 2 to the 15 is not going to work because that's a way big number. 2 to the 10th is 1,024, so 2 to the 15th is not going to be 30. Okay. You're just kidding. Okay, thank you. All right. There's not a power of 2 that equals 30, or a nice power. Okay? There is a power, but it's not a nice power. We'll talk about what it would be later on. But for right now, we'll just say it's not a nice power. Okay, not a nice number. Not an integer, let's say it that way, or rational. We'll come back to that. Okay? We'll do this later. Just not right now.